Hello, this is going to be our first lecture for solutions. This is actually going to be our Unit 10, lecture number 1. There are going to be about 3 of these total for Unit 10, talking about our solutions unit. So solutions are very important for us. You actually probably use solutions on a regular basis without thinking about it. So here's what a solution is. A solution is a homogeneous mixture of two or more substances in the same physical state. So there are two types of mixtures, heterogeneous and homogeneous. Homogeneous is where the mixture is going to look the same throughout. So meaning you're not going to be able to see the small pieces of your solute or solvent. No pieces. Okay. If you were to have a heterogeneous mixture, that's where you are going to be able to see the different parts. So my go-to example of a heterogeneous mixture is going to be like trail mix. Okay. But a solution, like what we're going to talk about today, is where it looks the same. There are, you cannot see the individual pieces. And so my favorite go-to example for this one is going to be Kool-Aid, because I hope that we've all had a delicious, delicious glass of Kool-Aid on a hot summer day. So in order to make Kool-Aid or make some sort of solution, you need two pieces. Okay, so every single solution is going to be made of a solute and a solvent. So the solute is the substance that is being dissolved. So typically another good example would be like salt water or sugar. So this is going to be our Kool-Aid packet. Or maybe you drink coffee, right? So that would be the sugar or the creamer that you put in your coffee. And then your solvent is the material in which the solute is dissolved. So typically, the universal solvent is going to be water. Okay, but you could have a different solvent, like I just said, if you're making coffee, the actual black coffee would be your solvent, and you dissolve the sugar in it to make it maybe taste a little bit better for you in the morning. So every single solution is made of a solute and a solvent. Solute, solvent. The solute is what is being dissolved, and the material and the solvent is the material that does the dissolving. So here's an example just to show you that we have our solute of salt, and this would be our solvent of water. So there is more solvent than solute in a solution. So the solvent is always present in greater amounts. Okay, present in greater amounts. So there is a limit to what can or cannot be in a solution, like what can or cannot dissolve. And that is given by a new vocabulary word called soluble. If a substance is soluble, that means that it is able to be dissolved. You can dissolve it to where you're not going to see the individual pieces, because remember, we want to make a homogeneous mixture. Oh, sorry. After this picture, if we were to stir in the salt, you're not going to be able to see the individual salt grains anymore. It will be a homogeneous mixture. So if something is insoluble, that means it will not dissolve. So that's going to be like oil and water. So you can very clearly see we have a line for the oil, and then we have a line for the water. So you can't just mix whatever solute with whatever solvent and then just make a solution. There are some rules that you have to follow. And this is the main big rule for solubility. Solubility, or whether something is able to be dissolved, is governed by like dissolves like. So that means that polar solutes will dissolve in polar solvents, and that nonpolar solutes will dissolve in nonpolar solvents. So polarity matters. Polarity matters. Okay, so we talked about polarity in Unit 4 where we had Lewis structures. And we talked about how polarity is a separation of charge. Okay, you're not going to have to draw Lewis structures or anything here, but I do want to talk about how polarity is affecting solubility. So, our polar solvent water, H2O, is polar. So anything that's polar is going to be able to dissolve in water. Okay? Also, anything that's ionic, so like NaCl, it's going to be able to be dissolved. But water cannot dissolve nonpolar solutes. So water can dissolve polar and ionic, but not nonpolar solutes. But if you were to have a nonpolar solvent like oil, it cannot dissolve polar solutes or ionic solutes. They are just, if oil was mixed with a polar solute, they're just going to separate out, just like that picture showed a minute ago. But you are going to be able to dissolve any nonpolar solute into a nonpolar solvent like oil. So, again, soluble means being able to be dissolved, or the solubility, okay? So, for example, salt and water, we have an ionic solute dissolving in polar water, our solvent, okay? If something is insoluble, it will not dissolve. So like oil in water, non-polar oil does not dissolve in polar water. So like dissolves like is our big key. Like dissolves like is our major rule for solubility. So this is why oil spills are a big deal. If you were to have oil spilt in the ocean, that's why the oil sits on top of the water the way that it does. So molecules with similar forces are able to dissolve in each other, but water molecules cannot dissolve oil, a nonpolar substance. So there are lots of different methods to actually be able to clean up oil spills and be able to, rescue poor little animals like this bird that's on our screen. So you're actually going to use what's called a dispersant. So it's just a type of nonpolar chemical that's going to be able to dissolve the oil layer of the oil, instead of just letting that oil sit there and ruin nature. So if something is soluble and we're following the like dissolves like rule, okay, we can make solubility better. So that means that we can make things dissolve faster. So am I going to be able to dissolve a solute better? Because we want to make sure that we're dissolving everything that we have as quickly as we can. So if you increase the temperature of dissolving a solid in a liquid, you're going to increase the solubility. Some of you, especially if you work in fast food, have probably already seen that. If you have to make the tea for whatever restaurant you're working for, you're going to make sure that you're dissolving all of that sugar while your tea is actually warm, because then it's going to dissolve better and you're not going to have big sugar clumps at the bottom. Okay? Changing the pressure has no effect on changing the solubility of a solid in a liquid. But another thing that you can see, that I know that you've seen in your life already, is that stirring makes dissolving happen faster. If you were to just make Kool-Aid and dump the sugar packet into the water and then just leave it there, you're going to be waiting a long time for those sugar molecules to dissolve. So naturally, we all start stirring to kind of make the process happen faster. So stirring works because it's increasing the kinetic energy, or it's increasing our motion. So we talked about kinetic energy in Unit 9, the energy of motion. So if your molecules are moving faster and they bump into each other more often, then they're going to dissolve. Now, another way to increase the solubility of solids in liquids is to make sure that you use smaller pieces. So having an increased surface area. So if we increase the surface area, this is going to be like using a sugar cube versus granular sugar. Okay? If you were to just dump a sugar cube into the tea that you're making for the restaurant where you work, the sugar cube is going to take a very long time to dissolve. But if you use granular sugar and you stir it up, then your solution is going to be made much more quickly. Now, gases and liquids. This is like everyone's favorite and delicious soda. Okay? So, soda is a mixture. It's a mixture of gases, carbon dioxide bubbles in liquid. Also, obviously, there's lots of different types of sugars and dyes present when you have soda like Dr. Pepper or Cherry Coke or grape soda. So, if you increase the temperature, you actually decrease the solubility of the soda. So, that's like when soda goes flat. Okay, so if you increase the temperature of your soda water, you actually make the carbon dioxide bubbles come out of the solution. But if you increase the pressure, then you increase the solubility. So again, think about a can of soda. When you open a can of soda, you're releasing the pressure. Okay, as long as the soda can stays nice and secure, or the lid of your soda stays nice and secure, then you're going to have that nice bubbly carbonated soda. But as soon as you open the container and decrease the pressure, then that means that the gases, the carbon dioxide, is going to not be dissolved anymore. Okay, if you stir soda, the bubbles leave solution. So again, you've seen that. Like if you shake up soda, it goes flat. Being flat means that the gases are no longer dissolved into the liquid. So you can see that gases, or our soda, or whatever we're drinking, whenever we drink soda, has opposite effects than, say, this when you try to dissolve a solid in a liquid. So that brings us to the end of this lecture. So, big key ideas. We went over several vocabulary words. We went over solubility, whether something's soluble or insoluble. We talked about solutes and solvents. And we've also gone through and looked at how to make our solutions better. So whether you have a solid in a liquid or a gas in a liquid, you're going to be able to change the surroundings and make the solution happen or dissolve faster if you're able to change these certain instances. So thanks for watching. Hope you were taking notes, and you guys can get started on your check-in quiz. Thank you.